With this proof, we're given RV is congruent to RC, angle 5 is congruent to angle 6, and angle C is congruent to angle V. So write all that given down. RV, that segment is congruent to segment RC. Angle 5 is congruent to angle 6. We've been talking about in class every time that you see a proof and given information, you want to look through there and look for vocabulary words. We have no vocabulary words here, so we go to the next step, and we kind of fill things in our picture that we know. We know RV, that segment there, is congruent to RC, which is that segment there. We know angle 5 is congruent to angle 6. So these angles on the outside are congruent to one another. What would be nice is if we actually knew the angles on the inside to be congruent to one another. And that's really the task of this proof, is to know something about the angles on the outside and see if we can work our way into the inside. So that's where we'll kind of start here. And we could start somewhere else. We could say that RD is congruent to RD because that segment's in both triangles. Maybe we'll go ahead and do that. RD is congruent to RD. And that's the reflexive property. But because that property, that statement has no bearing on angle 5, angle 6, angle 3, and angle 4, and what we're about to do with those, this statement could come now, or it could come after what we're about to do. Okay. We want to look at this picture, and we can recognize that angle 5 and angle 3, they're a pair of adjacent angles that form that straight line. Okay? And when we have adjacent angles that form straight lines, our angle addition postulate tells us when two angles are adjacent and they form a straight angle, which we refer to as a straight line, then their sum is 180 degrees. So I want to take measure of angle 5 plus the measure of angle 3 and set that equal to 180 degrees. Okay, and that reason is the angle addition postulate. If you find in your book where they state the angle addition postulate, you'll find that it's in two sections. It's in two parts, part A and part B. Part B refers to this statement. Okay, so if you don't believe me, look there. We could say this a similar statement about angles 6 and 4. They form that straight line. Okay, so their sum is going to be 180 as well. So I'll say measure of angle 6 plus the measure of angle 4 is equal to 180 degrees. Okay, and I'll just leave that as statement number 3. Put those two things together because they have the same reason. Now in the past we've talked about seeing patterns, and this is a pattern that we'll see over and over and over again inside of proofs. Once I have two things that are equal to the same value, I can have measure of angle 5 plus measure of angle 3 equal to 180, measure of angle 6 plus measure of angle 4 equal to 180. I'm going to now say, well, this thing here is going to be the same as that. Okay? Because they're both equal to 180, so let's just make the measure of angle 5 plus measure of angle 3 equals 180, and 180 is equal to measure of angle 6 plus measure of angle 4. So we'll go ahead and state that measure of angle 5 plus measure of angle 3 was equal to measure of angle 6 plus measure of angle 4. Now the correct reasoning here is transitive, okay, but I would accept substitution. Okay. Remember that sometimes transitive and substitution will work. Either one will work. I'll accept either one, but there are specific times when only substitution will work and transitive won't work or won't be accepted. Now I recognize a additional step that provides me basically another pattern. Whenever I have two things on the left-hand side equal to two things on the right-hand side, two angles on the left, two angles on the right, and they're really not angles, they're measurements of angles, so these are really numbers, okay? They're representing values of angles. I want to look and see what is on the left-hand side that is also on the right-hand side. Okay? And if I look in terms of symbols, measure angle 5, nowhere on the right-hand side do I see measure angle 5. If I look at measure angle 3, nowhere on the right-hand side do I see measure angle 3, and vice versa with 6 and 4. Okay? But I do see values that show up on the left and values that show up on the right. We were initially told that angle 5 and angle 6 were congruent. So I know that the measure of angle 5, whatever that value is, it shows up on the left. Measure of angle 6, whatever that value is, it shows up on the right. Okay? Now, before I do what I'm about to do, I need to say that because angle 5 was congruent to angle 6, I can now say that measure of angle 5 equals measure of angle 6. And that is the definition of congruency. Now, the reason I say that is because I want to eventually subtract this from the left side and subtract this from the right side. In order to do that, I need to make sure that I'm talking about measurements. If I just wrote angle 5 congruent to angle 6 and try to subtract them there, I would actually be subtracting a value, a number, a whole number, maybe not even a whole number, but a real number from a actual figure of an angle. Okay, so I took angle 5 minus measure of angle 5. That doesn't make any sense. One of these is actually a figure. This is a value. You can't subtract figures and values. They both have to be values. So that's why we want to change from congruency to equality. A lot of people struggle with that concept or that idea. Once I recognize that these two things are equal, get rid of these. Once I recognize that my measurements are equal and that this statement, or if these things could cross out, I'd be left with measure of angle 3 equal to measure of angle 4. Okay? And actually eliminating those things from the left-hand side and eliminating from the right-hand side, I've essentially gotten rid of the same thing from both sides. And when you have any equation where you remove something that is equal from both sides, that's subtraction. Okay. Now I'm not worried. In order to show these triangles congruent, we don't want to know that their measurements are equal. We want to know that the angles themselves are congruent. So whenever I have equality, I can change that to congruency through the definition of congruency. Now that will allow me to go up into my picture and say that angle is congruent to that angle. Okay. And we had, I erased them earlier, but we had RC congruent to RV, that was given. We found RD congruent to RD as the reflexive property here in step 2. So now, if I look at the parts that I have, highlight these, we have a side, an angle, and a side, congruent to a side, an angle, and a side. Okay, so you've got SAS there, so let's say that those two triangles are congruent. Step 8, triangle, let's go RCD is congruent to triangle RVD. My reason we said was side angle side. And now that I've got side angle side, that's not what we wanted to prove, but we did want to prove that parts of these triangles were congruent. So angle C and angle V, they're corresponding parts. If I look at C is the middle term here, V is the middle term there. So step 9, we can say angle C is congruent to angle V. And my reason will always follow SAS or SSS or ASA is corresponding parts of congruent triangles are congruent, CPCTC.